In this class, we have to discuss about the techniques of development in the flow in the various flow directions. And the techniques in the paper chromatography. What is the techniques we have to use it in the previous classes? One is the radial development, another one is the ascending technique, another one is the descending development, ascending, descending, and radial development. This is called the three types of techniques. Ascending of the paper means from bottom to top, from bottom to top. We have to mention about that one paper. We have to use that one filter paper is the stationary phase. In filter paper you have to contains that small water particles are present. Did not touch any other your fingers. Just we have to carefully draw the baseline and hang that baseline. We have to insert on the your sample 1, 2, 3, 4, just like that. That is called baseline. Suppose the one precaution is most important for that one. That is called the baseline is not immersed to that solution. Baseline is not immersed to that solution. Because suppose you have to miscible with the solvent, definitely that will be collapsing of this experiment. Ascending, that is the one most important precaution is there, that your sample is did not any match. That is called the miscible. That is the most important precaution. And after completion of the elution of the samples and a solvent, we can calculate the RF values by using the ascending technique. In the descending technique also same. In the descending means from bottom, from top to bottom. From top to bottom, we have to components or spots are present in that particular sample. This is called anti-chiffon rod. Anti-chiffon rod and the spots are present. And slowly they are migrating this substances. One spot is there, another spot is there, another spot is there. We have to calculate the RF value. This is called the baseline. This is called ascending technique. Another one is the radial paper chromatography, circular phase. This is called the wick. We have to put on the sample in the circular phase. This is called the wick. Sample is put on that one. You have to mention the one first, second, third one. That is different in your whatever the components present in that particular sample in the different length of the paper. That is called the RF values may be calculated. That's why the three techniques are present. One is the ascending of the paper chromatography, second one is the descending of the paper chromatography. We have to Another one is the radial paper chromatography. Another one is the most important in the paper chromatography is the one-dimensional paper chromatography. One-dimensional paper chromatography we have to use for the complex involved in the depends on type of complexity involved in the analysis for the chromatography. The one-dimensional paper chromatography depends upon the type of complexity involved in the analysis. Suppose you have to take the filter paper, usually 15 to 30 centimeters in the length, and 1 to several centimeters in the width in the first slide flat. Suppose my very tiny to drop, that is called minute drop of the sample solution, is placed in the one center in the baseline. In 1 inch from one end of the paper and its position is marked by just like our lead pencil. In the original solvent is also allowed to the evaporate, that is called as the mobile phase in the spot of the sample, and the spot of the sample and allowed to dry and allow to sample to move that mobile phase to carry that your components, and then remove that paper in the chamber and then dry in the one-dimensional paper chromatography. You see the paper clip in the this is called baseline. This is called the sample. This is called the anti-chiffon rod. In the glass cylinder, we have to hang it just like that. What is the multi-dimensional paper chromatography? Is there multi means two or more, including all the procedures which the development is repeated after one development is completed. One development is completed, you have to take the another development, and another development is completed and you have to take the initiated the third development. That is called multi-dimensional paper chromatography. That is called multi development means the chromatography repeatedly, not more than three. That is called repeated. Chromatography is repeatedly developed in the same direction and the complete the resolution of the two or more substances which have RF values close together can be obtained. The mobile phase one can use either the same solvent system or the different solvent system. You have to take the one solvent, okay, no problem. You have to take the two different solvents, okay, no problem. We can use that just like that our your multi-dimensional development. Second one is the two-dimensional chromatography is there. What is the two-dimensional? When a large number of substances are separated, single chromatogram. Large number of substances means you have to take the 3 or 4, not more than 3 or 4, 10, not more than 10, 10 above. Our substances are separated on a single chromatogram means single, uh, just like our colors. The development of the direction particular to the first and the with the solvent with the solvent are different from used the initial and of it necessary. The sample is applied on the one corner of the square piece of the paper and development in the first solvent paper dried. Rotate the 90 degrees, sorry, this is called 90 degrees and develop the second direction. One direction is used in one solvent and the other one is the same solvent used for the second direction and 90 degrees of the paper and differently to, we have to use that mobility of the solvent automatically your substance contains the so many components are present in the solutes are present in your sample definitely resolved in almost all 100 components of the resolved by using that two dimensional paper chromatography. The different types of solvent systems are used in one direction. It is essential for the first solvent to be completely volatile. Most important precaution, most important condition is that different types of solvents used in the system for the one direction. Maybe one solvent uses to another one is the different solvent is, but it is essential. Most important is it essential that first solvent to be completely volatile. After evaporating, after volatile, then only we have to use that second solvent. That is the most important. We have to take this one. You have to take the paper chromatography just like that your paper in your screens. You have to take that. This is called the baseline. Baseline. You have to took on the sample. You have to one that is called the blue, and that is put on insert on the chamber, and that your container. Okay. After that, we have to take that one. This is called the solvent. In that, this is called in that particular solvent. Solvent is not immersed to that your solute. Okay, and then solvent moved. That is called the mobile phase. Solvent moved from bottom to top. Your substance that your substance means your solute, your sample moved from up to this type this much of length in that paper. This is the one dimensional paper. After the completion of that paper, in that paper will be rotated after 90 degrees centigrade. This is the solvent you have to put on the paper. We have to use that one in that insert on the same chamber and using the different solvents you have to move that one. We have to move the your contains the one spot got to the two substances, that is called the resolved by two dimensional paper chromatography. Just like that, we had already one dimensional paper chromatography is the ion. In the development of the chromatogram, only one direction is quite satisfactory. Separation of the many mixers. This is quite satisfactory. We have to you see that your sample contains the A, B, C, D. AB is the stick on that one. C is the stick on that one. You don't know about this one. And D is also there. A, B, C, D in one direction. This is only single solvent. In the first solvent, we have to use that paper chromatography technique. One dimensional, we have to mixer. AB is there, C is there, D is there. Only one solvent, first solvent. After the, we have to use the another solvent. That is called the rotating that paper 90 degrees and two dimensional paper chromatography, one dimensional paper chromatography. After the completion of the one dimensional paper chromatography, we have to use the second direction, that is called the two dimensional paper chromatography. All the components present in that A, B, C, D are separated. You see this picture, A is separated, B is separated, C is separated, D is separated, E is separated by using the two-dimensional comparison of the one-dimensional and two-dimensional paper chromatography. This is the main difference between the one-dimensional and two-dimensional. In the one-dimensional only we have to take that some complexity components. Why are you using the two-dimensional paper chromatography? Your sample contains the lot of complexity solutes is present. We have to must apply, you must apply mandatory for the two-dimensional paper chromatography. Then only we have to separating of all the components by using this paper chromatography. But for complex mixers where the separation remain, what is the incompleting of the above method, two-dimensional developments, that is the development of the chromatograph using the solvent right angle to the first we carried out and better separation of the this component after completion of the your spots and then completed drying the paper, the turned through the 90 degrees of the chromatography and developed with the different solvent, just like that already mentioned that this one dimensional and two dimensional paper chromatography used, then definitely we resolved the all the complexity materials. You have to separating the uh, solutes present in your sample. That is called two dimensional. That is most important for that choice of the solvent. Solvents are most important. This is not suitable solvents may be used. That is called the polar solvents. Polar means the dipole moment. Common solvents are the polar solvent, but choice depends upon the nature of the substance to be separated. Nature of the substance. What is the nature? Substance may be very different types of nature is there. Nature of substance we have to separate it. Water miscible solvents such as the furon, propanol, metanol, etc. like that. We have to single solvent such as water, single solvent. We have to use the same water can be developing the chromatogram. If suppose you have to take the pure solvents, do not give the satisfactory separation. Sometimes may be happen. If pure solvents or solvent do not give the satisfactory separation, the mixture of the solvent suitably polarity may be applied. We have to apply that solvents in the polarity. Definitely polarity is applied, then only we have to satisfactory for the separation of the 100% separation. That's why added solvents may be either acids, bases, or complexing agents. These are the added solvents. In most cases, what are the used in the mixture of the components in the solvents, N-butanol, acetic acid, and water has been used. These are the mixing of that all the solvents you have to separation, satisfactory separation means that is called the 100% of the solvents may be separate. This is called the most important in the paper chromatography choice of the solvent. Choice of the solvent. What are the applications of the paper chromatography? Paper chromatography is the analysis of the drugs. We had already mentioned about that one. Drugs of the chemical and biological origin, plant extracts. Separation of the carbohydrates, that is called the sugars, vitamins, antibiotics, proteins, alkaloids, and glycosides, and identification of the drugs, we have to use that one of the most important application. And identification of the impurity, is there any impurities present in that sample, we have to purification of that sample by using this technique, definitely lot of help. And identification of the related compound, is there any related compounds is present in that particular sample, we have to get identified. And identification of the foreign substance, what do you want substance, and other than that one we have to mention that foreign substance in drugs. That is called the little bit of the impurities present. And identification of the decomposition of the products. Is there any your product contains decomposition? How much quantity of the different components are decomposed in your sample, your product? Definitely, we can identify this decomposition of the products by using this paper chromatography technique. And another one is the analysis of the metabolites of the drugs in blood, urine, etc. In the excretion of the urine, excretion of the blood, we have to metabolites. How much quantity of the metabolites in your blood streams in the patient's blood? Definitely, we can analyze by using this whatever we called the paper chromatography. I had to take that drug erythromycin isolate, and the mobile phase is the isobutyl methyl ketone, detecting as a nutrient agar containing the bacillus in the families. Gentamicin drug, that is the chloroform, methanol, ammonia, water, 10 is to 3 is to 2, ninhydrin in the pyridine acetone mixer in the Vancomycin, that is called the tetraacetyl alcohol, acetone, and water, 2 is to 1 is to 2. That is a nutrient agar containing the bacillus subtilis. And hydroxy, suppose the hydroxylobolamine, S-butanol, acetic acid, potassium cyanide, and the detecting agent, elution and measurement of the substance by 361 nanometers. After the completion of the RF value, already mentioned about that one. Is there any effect of the RF value? Definitely. First affected by the temperature. Higher temperature, you have to take the midsummer, your laboratory temperature is very high, then automatically RF value may change, definitely change. That is the most important affecting of the RF value. Another one is the most important for the affecting this is the solvent used. Solvent may be purely solvent used. Suppose 99%, suppose you have to take the 98%, suppose you have to take 78% of the pure solvent, that is the most adverse effect on the your RF value. And also most important thing is the quality of the paper. Quality of the paper means your paper contains the water between the two cellulose paper, 100% purify the paper, then only you got the good results for the RF value in the paper chromatography. Is there an impurities present or reversible adsorption may be present, that not help in the RF values. The distance traveled by solvent and the solution, most important affecting the RF value. In the chemical reactions between the substance being the partition of the pH of the solution, the concentration of the separated substance. Techniques of the paper chromatography is involved practical choice of the filter paper, preparation of the solution, application of the sample to paper, and choice of the solvent, development of the copper, and drying of the paper, the quantity estimation. Is there any precautions using the paper chromatography? Definitely, so many precautions are. Minimum value of the concentrated solution in the sample. Minimum value should be applied in the chromatography paper. And the other one is the complex agent should not be unnecessarily used. Solvent for the elution should be properly selected, and the reducibility solvent should be selected, and vapor solvent equilibrium should be properly established. Precautions, these are the some precautions in the paper chromatography is the in precautions is there. With the help of the paper chromatography, we have to analyzing the component separation, we have to lot of helpful for in the society by using the paper chromatography in the society, but because the paper chromatography easily most easy technique and versatile technique and wide applications, we have to use the paper chromatography.